Good morning, students. In last class, we are completed organic chemistry topic, alcohols, phenols, and ethers. See, in ethers, we discussed about preparation of ethers, chemical reactions of ethers, and chemical reactions of any sort. Among that, in preparations of ether, the Williamson synthesis, see, when sodium alkoxide is treated with an alkyl halide and ether is formed, a well-known named reaction repeatedly asked in your annual examination. Dear students, alcohols, phenols, and ethers, we shall have some revision. See, alcohols with a functional group R-OH, and ether, see, which is nothing but R-O-R dash, and phenol, a benzene ring with hydroxy group. So, alcohol, ether, phenol. See, in phenols, some of the named reaction. In the preparation of phenol, we have to concentrate on cumene process. In preparation of phenol, we have to concentrate on cumene process, and even in the reactions of phenol, you have to concentrate on coal-base reaction as well as Reimer-Timmermann reaction. In ether, the Williamson ether synthesis, and in alcohol, see, dehydration mechanism. See, every year you are going to have a question how ethene is prepared from ethanol. See, dehydration of ethanol to ethene. See, these are some of the questions which can be asked for your annual examination. See, we are completed alcohols, phenols, and ethers. Write down the notes, and some part again we have to send, and the next part of the notes I will send today or tomorrow. And today we shall discuss begin with a new topic, that is aldehyde, ketones, and carboxylic acid. See, aldehydes, which has a functional group R C double bond O H, and generally we will call this as RCHO, which is aldehyde. See, you can see here the carbonyl functional group. Carbonyl functional group. See, carbon with oxygen. See, carbon is bonded to oxygen atom. And here carbon is sp2 hybridized. And this particular group is called carbonyl group. Are you clear? See, in a carbonyl group, the carbon atom and the oxygen atom with a double bond. Here carbon atom is sp2 hybridized. So, if this class of compound is called aldehyde. Are you clear? And in the carbonyl, carbon to oxygen double bond, so you can find an aldehyde functional group. So these class of compounds are called aldehydes. And oxygen atom is bonded to hydrogen atom. And ketones, even again, the common functional group is carbonyl group. for ketone. And this carbonyl group is attached to two other carbon atoms, and we will write, see, R C double bond O R dash, and these are called ketones. See, general formula of the compound. The general group which is present in aldehydes, ketones and carboxylic acid is carbonyl group. Dear students, you have to emphasize, you have to concentrate on carbonyl. See, this carbonyl group is attached to an hydrogen atom. Such compounds are called aldehydes. Carbonyl group is attached to two other carbon atom of the alkyl group or aryl group. They are called ketones. If carbonyl group is attached to, see, this carbonyl group is attached to an oxygen atom, and they are called carboxylic acid. They are called carboxylic acid. I think you are clear. See, aldehydes with a functional group CHO. See, aldehydes with a functional group CHO. We can write this. See, R C double bond OH. So, which is nothing but aldehyde. And ketone. See, R here C double bond O, which is nothing but a ketone, and R dash, which is a ketone. See, carbonyl group is attached to two other carbon atoms. Here, carbonyl group is attached to an hydrogen atom. If you go for carboxylic acid, R C double bond O and OH, carbonyl group is attached to an oxygen atom. Carboxylic acid. So, in aldehydes, ketones and carboxylic acid, the common functional group is carbonyl group. Are you clear? Common functional group is carbonyl. Common functional group. So, carbonyl group. See here, functional group is aldehyde. For ketone, a carbonyl group, and for carboxylic acid, we will write COH. Are you clear? These aldehydes, ketones are mainly synthesized by plants and animals. In our everyday, day-to-day life, we can find these good, pleasant, best odor, the fragrance. That means the odor. See, these aldehydes and ketones are present in all types of different types of plants and animals. And we can observe that fragrance, a pleasant smell in a forest region, anywhere if you are going to move, there you can find a very good pleasant odor. See, salicylaldehyde, cinnamaldehyde, vanillin, all these are examples of aldehydes and ketones. See, you have to remember the functional group R C double bond OH and R C double bond OR dash and carboxylic acid R C double bond OH. And derivatives of carboxylic acid are, again, you can find ester group, see, ester. In ester group, R C double bond O, and here OR dash. And it is nothing but a derivative of carboxylic acid. Instead of OH functional group, we have OR dash. And these class of compounds are called ester. Are you clear? See again, R C double bond O, a carbonyl group. which is attached to an amide group, then it is called amides. These are called amides. All these are derivatives of carboxylic acid. Again, acid chloride, acyl chloride, C double bond O and X, which is called, if it is Cl, we can call this as acid chloride. Are you clear? It is nothing but acyl halide. These are called acyl halides. We can take here then X, where X is an halogen. It may be chlorine, bromine, iodine. See, we have aldehydes, ketones, and carboxylic acid. Again, derivatives of carboxylic acid we can find are, see, they are esters, amides, and acyl halides. And another class of derivative of the carboxylic acid only, they are called, see, anhydrides. See, anhydrides, which contains a carbonyl group, which is bridged with an oxygen atom, again a carbonyl group, and R dash. So this is called anhydrides. Are you clear? These are called anhydrides. R, C double bond O, then bridge with oxygen atom, and C double bond O, R dash. So we can also write like this. See, R, C double bond O, and again R, C double bond O, which is bridged with an oxygen atom, and it is called anhydrides. See, first we have to identify the class of compounds, different class of compounds. So different class of compounds are aldehydes, ketones, carboxylic acid. And aldehydes have a functional group CH. Ketones have a functional group R, C double bond O, R dash, and its functional group is CO. And carboxylic acid, the functional group is COOH. The basic functional group which you studied in first PUC itself. Again, the derivatives of carboxylic acids are, see, esters, amides, acyl halides, and as well as anhydrides. Are you clear? See, how to, if you know the general formula of a particular class of compound, any type of chemical reactions you can easily write. And these aldehydes and ketones will experience in our day-to-day life. See, some of the organic compounds which secreted in plants, which have a fragrant, pleasant odor, and those are nothing but they are aldehydes or ketones. For example, cinnamaldehyde, see, formula of cinnamaldehyde, a benzene ring, see, CH, double bond CH and CHO. So it is cinnamaldehyde. Then even you can write vanillin. See, vanillin, OCH3, then OH and CHO. So this is nothing but vanillin. And even salicylaldehyde, say salicylaldehyde, CHO group and OH, which is nothing but salicylaldehyde. See, all these which can be extracted from the plants, and it gives a fragrance. Fragrance is a pleasant odor. Suvasana anta karitharu. Suvasana. So all these are aldehydes, and we shall study the chemical part of these aldehydes. Okay. So dear students, aldehydes, ketones, and carboxylic acid. How to write their general formula? It is on the board. You have to be very clearly, you have to observe, and you have to write. Then we shall study the next part of, that is the aldehydes, their nomenclature, common name, and IPC. See, in aldehydes, the functional group we can find is CHO, and ketone R, C double bond OR dash, And in carboxylic acid, we can find RCOOH. See, in aldehydes, we shall study about aldehydes. Aldehydes. See, its functional group is CHO. And it can also be written as C, then again H. Are you clear? This is nothing but an aldehyde functional group. And we shall study some common names, or which is also called trivial name. See, aldehydes, even today, even though IUPAC systems are there, they are well known by their common names. Even today, all aldehydes are well known by their common names. See the common name, take for example, say CHO, then CH3, CHO, which is called acetaldehyde. See, we shall study IUPAC name later on. As these functional group is attached here, and this is nothing but a hydrocarbon, methane, a derivative of methane. One of the hydrogen atom is replaced by CHO, and generally we will call this as acetaldehyde. Its common name is acetaldehyde. Go for common names of ketone. Ketones also, still today, they are well known by their common names. Say CH3, C double bond O CH3. See here again, carbonyl group is there. It is a ketone and its common name is acetone. A well-known organic compound which is used in many syntheses and which has a pleasant odor in the preparation of paints and all types of fragrance. We can use acetone. CH3, C double bond O, CH3. And these class of compounds, even aldehydes and ketones, in the naming, they are well known only in common names. See, if you go for HCHO, and it is nothing but formaldehyde. See, these common names are derived from the basic carboxylic acid, or these are also named as by Greek or Latin words. And HCHO is called formaldehyde. And it is just add water to this, it is converted into formalin, which is used to prepare the biological specimens in laboratory. Again, so this is formaldehyde and this is acetaldehyde. Aldehydes and ketones are well known by their common names. Are you clear? They are well known by their common names. We shall go for again. See, suppose an aldehyde group is attached here, and so many carbon atoms are there. CH2, CH, Br, then again CH2, again CH3. See, this carbon atom where aldehyde group is attached to this carbon atom, and we will call this as alpha carbon. And like that, beta, gamma. So, in the nomenclature of the common name, we can write, see, beta bromo. See, how many carbon atoms are there? 1, 2, 3, 4, 5. See, beta bromo, here, pentaldehyde. Are you clear? So, this is nothing but the nomenclature in naming the aldehydes in common name. The functional group attached carbon atoms and next carbon atoms is represented as alpha, beta, gamma. And if you go for the ketones, the carbon atom adjacent to carbonyl functional group, they are represented as alpha alpha dash, beta beta dash, and gamma gamma dash. Like that it continues. It continues. Are you clear? So this is the common name of aldehydes and ketones. Even today, aldehydes and ketones are familiar by their common names, particularly acetone, formaldehyde, acetaldehyde, benzaldehyde. All these are well known by their common name only. See again, then aromatic aldehyde, which is called benzaldehyde. What is the formula for benzaldehyde? Benzene ring and aldehyde, which is called benzaldehyde. Benzaldehyde. Are you clear? So this is benzaldehyde, again formaldehyde. All these are common names. Aldehydes and ketones are still today they are familiar by their common names. Are you clear? Okay, then we shall continue with the IUPAC naming of aldehydes and ketones. See, IUPAC naming. IUPAC naming. In International Union of Pure and Applied Chemistry, say CH3, CHO, a simple hydrocarbon where one of the hydrogen atom is replaced by an aldehyde group. How many carbon atoms are there? Two carbon atoms, one to the functional group and another to the parent chain. So therefore, its name is ethane. And ending E is replaced by Al, by the suffix Al. It is called aldehyde. Are you clear? So therefore, its IUPAC name is, say, the basic hydrocarbon is ethane. Ethane. E is replaced by Al. So that is nothing but the suffix. So you studied this in first period. So therefore, its name is ethanol. Ethanol. Are you clear? Are you clear? See how many carbon atoms are there? So simple hydrocarbon name and end E is replaced by an Al. That's all. So this is called, see, ethanol. Again, CH3, CH2, CHBr, again CHO. See, you have to write its IUPAC name. See, we have a functional group here, and the numbering of the carbon atoms should be start by the functional group. 1, 2. So, second carbon atom have the substrate, then 3, 4. So, therefore, it is 2-bromo. 2-bromo. How many carbon atoms are there? 4. Therefore, parent hydrocarbon is butane. So, therefore, it is butanol. Butane. Are you clear? So it is, say, 2-bromo-butanol. So this is how we can write IUPAC name of aldehydes. If a cyclic aldehydes are there in a ring, take for example, say cyclic aldehyde. And suppose one aldehyde group is here. Are you clear? So it is nothing but cyclo 1, 2, 3, 4 cyclobutane. See, entire name we have write cyclobutane, and then we have to give a word carbaldehyde, and its name is cyclobutane carbaldehyde. Are you clear? See, there is nothing but cyclohexane. If suppose the cyclohexane contains a CH2 group, then it's called, see, cyclohexane or aldehyde. Are you clear? Its IUPAC name is cyclohexane or aldehyde. For a aldehyde group, if a cyclic ring is there, then its IUPAC name completely we have to write the particular original name of an organic compound, then 2-carbaldehyde to a functional group. If carbaldehyde functional group is there, you have to write carbaldehyde. See, therefore, its name is, it is nothing but cyclohexane. See, hexane, carbaldehyde. Are you clear? It is cyclohexane carbaldehyde. So, this is how we can easily write the nomenclature of aldehydes and ketones. See, if suppose 3 aldehyde groups are there, CHO, CH2, again CHO, again CHO, again CH2, CHO. See, in this example, you can find 3 aldehyde groups. One is here, another, and another. So, what is the parent hydrocarbon here? 1, 2, 3. Are you clear? It is a propane. Therefore, its IUPAC name is propane. See, 1, 2, 3, carbaldehyde. How many carbaldehydes are there? 3, right? Carbaldehyde. Are you clear? So, this is how to write IUPAC name of aldehydes. Are you clear? A very simple analogy. If ring structure is there, if more than 2 functional groups are there, then you have to use the word carbaldehyde. That's all. Are you clear? Even in for ketones also, say CH3, C double bond O, CH2, C double bond O, again CH3. See, ketones always they are present in the middle part. Ketones have a functional group C double bond O. So you can easily nomenclature 1, 2, 3, 4, 5. Now, see how many ketone groups are there? 2. At the second position as well as in the fourth position. So therefore it is parent hydrocarbon is pentane. See, pent 2,4 di-ONE. See, pent 2,4 di-ONE. If it is ketones, their suffix name is ONE. We have to introduce the suffix name ONE. That's all. So this is how we can easily write the nomenclature of aldehydes, ketones, and carboxylic acid. Are you clear? Okay, dear students, I will continue my next class tomorrow. So we discussed about only the basic general formula of aldehydes, ketones, and carboxylic acid, and nomenclature, common name as well as IUPAC name. We shall continue in next class. Thank you.